So good day. Our topic for today is all about Coulomb's theory of dry friction and the four different types of dry friction. So the theory of dry friction or Coulomb friction predicts the maximum friction force that can be exerted by dry or contracting surface that are stationary relative to each other. The friction force exerted by the surface when they are in relative motion or sliding. So now, I am discussing the four different types of dry friction. First is the static case theory. Coulomb proposed the following law. If there is no relative motion between two surfaces that are in contact, the normal force N and the friction force F satisfy the following relationship, such as force maximum is of the static friction force that can be exists between the contracting surface, and the coefficient of static friction is known as coefficient of static friction. The coefficient of static friction contracting surface, this is equation state simply that the friction force F that exists under the static condition has an upper limit that is proportional to the normal force. Second is the impending sliding. Consider the static case in which the friction force equal to its limit value, that is, force is equal to the maximum force is equal to the mu s, or the coefficient of static friction, N. For this condition, the surface are on the verge of sliding, a condition known as impending sliding. When the sliding impends, the surface are at rest relative to each other. However, any change that would require an increase in the friction force would cause sliding. The direction for the maximum force can be determined from the observation that force maximum always oppose impending sliding. The third one is the dynamic case. If the two contact surfaces are sliding relative to each other, the friction force F is postulated to be force is equal to Fk is equal to the mu k n, or the coefficient of kinetic friction, N, where N is contact normal force. Mu k is an experimental constant called the coefficient of kinetic friction, and Fk is referred to as the kinetic or the dynamic friction force. The coefficient of the kinetic friction is usually smaller than its static counterpart, as the static Fk always oppose sliding. So lastly, the fourth and final one is the further discussion of Coulomb friction. When applying Coulomb's theory, the difference between maximum force and the Fk must be clearly understood as force maximum, friction force that can exist under static condition, or Fk is friction force that exists during sliding.
So since we have finished discussing Coulomb's theory of dry friction, so I have prepared some example here so that we can solve it using one type of Coulomb's theory, which is static case. So here's the problem. The 100-pound block in the figure shown is initially at rest on the horizontal plane. Determine the friction force between the block and the surface after P was gradually increased from 0 to 30 pounds. So as you can see at the figure, we have given for the weight of the block, which is equal to 100 pounds, and the coefficient of static friction, which is 0.5, and the kinetic friction, which is 0.2. So since this problem is a static case, so we will going to use this formula. F maximum is equal to m Sn. So here 100 pound block weight is acting downward, so that there are force acting opposite on it. So when we push the block to the right, so since we push the block to the right at 30 pound, there are force or friction force acting opposite towards it. So equilibrium condition, so we have here we have sum up the force or the summation of force along y is equal to 0 when kung pasaka siya, it is positive. So n minus 100 is equal to 0, so therefore our n is equal to 100. So next, we sum up the force along x is equal to 0 if we're going to the right is positive. So P is equal to F is equal to 0. So therefore, our force is equal to our load is equal to our force is equal to 30 pounds. So here is our final since in the problem we determine the friction force between the block and the surface after P is gradually increased from 0 to 30. So we conclude that the force maximum is equal to ms equals to n. So we disregard the kinetic friction, which is the coefficient of kinetic friction, which is 0.2, since we use the coefficient of static friction, which is 0.5. So using the formula, F max is equal to coefficient of static friction is equal to n times 100, so that our force now is 500, or our final answer is 50 pounds. So because the force is less than or equal to force max, we conclude that the block of the static equilibrium and the correct value of the friction force is equal to 30 pounds.
To my YouTube channel, guys. Today I am going to make a new video, so please whatever. Please I want to reach 1 million likes. So please sarapakarai. Okay, thank you.